So now we're going to look at another geometric sequence question. This is one of the more difficult questions that I've ever seen. There's kind of a little trick to it, and if you don't get that trick, then you can go down a really, really messy way of trying to solve it. So it's much easier if you learn this kind of trick, and if you see this type of question, you'll be able to just apply the trick and you'll finish the question in half the time. So I'll have a look anyway. So I'll say the product of the first three terms in a geometric sequence is 216 and their sum is 21. So that means if you multiply term 1 by term 2 by term 3, you're going to get 216. And if you add term 1 to term 2 to term 3, you're going to get 21. It also tells us that the common ratio is less than 1. And then it asks us what are the terms. So we know that the general form of a term in a geometric sequence is going to be given by t of n is equal to a multiplied by or to the power of n minus 1. And so we'd probably think we'll go t1, we'll go t2, and we'll go t3, and we'll work those out. So t1 is going to be a or to the 1 minus 1, which is just going to be a or to the 0, which is going to be a. This is going to be a or 2 minus 1, which is a or to the 1, which is just equal to a or. And this is going to be equal to a or to the 3 minus 1 is equal to a or squared is equal to a or squared. So think these are your three terms. If you multiply them, you get 216, and then if you add them, you get 21. So we could write a multiplied by a or multiplied by a or squared is equal to 216. So that means we get a cubed or cubed is equal to 216, or else a plus a or squared is equal to 21. Now there is a way of solving those two, so basically you use those two and use simultaneous equations, but it's quite messy, so that's not the way we're going to do it. So I just wanted to show you that. If you do go down that path, try to spot that something like that is going to be really, really difficult to solve, so there's a much easier way of doing it. So I'm going to scroll down and show you that way now. So instead of taking the traditional look at the three consecutive terms, we say that the first term, okay, so I'm going to say t1 is going to be equal to a divided by or. We're going to say that t2 is going to be a, and then the t3 is going to be a or. Okay, and this is the trick that you're allowed to do for the question. A divided by or, a, and then a or. Because there's still three consecutive terms in a geometric sequence, because each time it gets multiplied by or. So if that helps to try and remember it, a divided by or, then multiply that by or, you get a. Multiply that by or, you get a or. Yeah. So what you do is you let those are your three terms. So that means the first line here says the product of the first three terms is 216. So we'll go ahead with that, and we'll see what we get. So we're going to get a divided by or multiplied by a or is equal to 216. So all of this is going to give us a cubed, because a by a, and then there's going to be an or and divided by or. So what's going to happen is this or will cancel with this or here, and we'll be left with a cubed is equal to 216. That means a is equal to the cubed root of 216, and that means a is equal to 6. So that's much easier than trying to solve those nasty simultaneous equations that take a lot longer. So a is equal to 6, and that's handy out. So now we can have a look at the second form. So it's not going to look like that, but we're going to say, I'll go blue. So remember, if you add all three of these terms, so a over or, a, and a or, we get 21, and that's what the second line tells us. Their sum is 21. So I'll go down and we'll say a divided by or plus a or is equal to 21. Yeah, and remember a is equal to 6, we've already figured out. So that means we're going to have 6 over or plus 6 or is equal to 21. So now we have to try and solve this. What I'm going to do, I'm going to multiply everything by or. So I'll write that, multiply by or, and then we're going to get, if you multiply this by or, you're going to get 6. If you multiply this by or, you'll get 6 or, and multiply this by or, you'll get 6 or squared, and this is going to be 21 or. Okay, so rearrange this. Scroll down a little bit. I'm going to get 6 or squared. It's going to be minus 15 or plus 6 is equal to 0. Divide everything by 3, and we're going to get 2 or squared minus 5 or plus 2 is equal to 0. Keep going. So we have to factorize this. So now we have a quadratic here that we want to solve for or. So I'm going to say equal to 0. It's going to be 2 or, and we're going to have minus 1 and minus 2. So our answers are going to be, we're going to have 2 or minus 1 is equal to 0. That means 2 or is equal to 1, or is equal to a half, squeezed in, or else we just have or is equal to 2 on this side. But the last line of the question tells us that, or the second last line, the common ratio is less than 1. And that means that this is going to be our answer. So obviously 2 is not less than 1. So we disregard that. And this is our answer. So that means we have a is equal to 6. And we have or is equal to a half. So we can write the first 3 terms. So box this off in green. We're going to do it here. So remember, the first term is a over or. So we'll say a over or. The second term is a. The third term is a or. So if we stick these numbers in, we get 6 divided by a half, and then we get 6, and then we get 6 multiplied by a half. So that's going to give us 12, 6, 3. Those are the first 3 terms. And you can check that if you multiply those 3 by each other, you get 216. And then if you add them all together, you'll get 21. So then you know that you're right. Is that all good? So hopefully that made sense. Basically the trick is to not do that. So if you do that, hopefully you'll spot that that's going to be way too difficult to solve. It is possible to solve it. It's just really hard. That's a much easier trick if you let one be a over or, second one be a, and then a or, and then it just makes things a lot simpler. And so that's a way to do those type of questions. We'll see you next time for one last geometric sequences question. So I hope you enjoyed it. Don't forget to like and subscribe, and we'll see you next time.